everybody. Zeus here with Sounds and Grounds. Thank you so much for continuing to check us out. We're now up to our magic number 11 session here in the format. Of course, we have today my partner, my good friend. He came for the first show and loved it so much he couldn't leave. Mr. Jack Costo of StEMPIRE. How you doing, Jack?
Hello, hello. I'm doing great. Got my coffee. That's all I need.
I have a coffee mug with grapes in it. How hardcore is that, right? And today we are so stoked. We have Leah Elson, who, if I run down the list of everything she's into right now, would be full 2 hours of a podcast. But she is the queen of the StEMPIRE. She is into all things science, educating, teaching the masses cool science stuff, and an author. Recently picked up No Stupid Questions in Science, which I'm kind of stumped. I'm working on a list of stupid questions and I'm going to submit those later. But
we're going to try really hard to find stupid questions.
Right. Yeah. All I have to do is lean political and I can have a whole 6 hours of stupid science questions. But Leah, thank you so much. How are you doing today?
Thank you for having me. I am doing fantastic. It's Saturday. The weather is great. You can't complain.
Groovy. Yeah, I was just talking to Jack previously about it's like 80 degrees here in Virginia and it's been like around 40-ish. So the heat and coldness back and forth, I felt like I was getting sick last week. I think my time is coming up here pretty soon.
Oof, I got sick recently, so I feel that pain.
Yeah, for real. So let's talk about a few things. We got a ton of cool questions. A lot of people submitted to your page. A few things I want to drop real quick because this week has been huge for you. Anyone that follows you on social media, you now have StEMPIRE Studios, which I'm assuming is a media production company type of thing. So we want to give you a section here just to sort of talk about that. And also the two programs you've come up with, which is What the Hell Do You Know, which is awesome. And then also Mysteries of the Scientifically Unknown. And you're big on the parentheses, so I'll continue with that format. So
I love it.
let us know in our followers, because people that follow us and know us probably don't follow you. I don't think there's a whole lot of crossover, but the fact that you're into metal is kind of what drew me in. So and I do have a non-linear way of asking a lot of stuff, so we'll really try to circle back to the previous part and just you can take it away with what you got.
That's great. I'm good with spontaneity. So I've been a science communicator as well as a scientist for the last 6 years. And my biggest claim to fame was 60 seconds of science and real science on Instagram. And it's very short form. It's meant to be digestible science answers that originate from public questions submitted directly to me. And I've been asked for 6 years to please do something long form that's more descriptive, that gives people something more to chew on. And so I founded StEMPIRE Studios this week, and this is meant to be sort of an umbrella parent company for multiple programs. It's sort of a sky's the limit type thing. But as you said, the two initial projects launching in December are What the Hell Do You Know? And that is a show that is based on just taking hot button pseudoscience circulating on the internet, the wildfire that is the internet of spreading misinformation, and scientifically debunking it and sort of putting a line in the sand. And then the second show is a crossover between fiction and nonfiction. It's called Mysteries of the Scientifically Unknown. And this is meant to focus on a small town where it is just plagued by a bunch of strange phenomenon. And even though it's a fictional town, these phenomena actually do occur in real life. So through the course of the episode, we will lead you through what the scientific background is for each of these very strange occurrences, like raining frogs or rocks that move on their own, things like that.
Right. That's cool. So these are both podcast formats that you're putting out?
They're both podcasts for now. Mysteries of the Scientifically Unknown has a trajectory of being animated at some point, but that's obviously a much larger undertaking. So that that's like second phase of this project.
Yeah, Amazon,
yeah.
Hello.
Hey, Hulu, Netflix. Like
Right on. That's so cool. So you just feel like more people wanted longer than the 60-second things that you're doing.
Yeah, one of the most common questions I get are, do you have a YouTube page? Do you do this, in a longer format? Or I love podcasts and I travel for work. Do you have anywhere that you have a podcast? And I had a podcast for a brief period of time, and it
Yeah,
is defunct now. But I received such great feedback from that, so I decided to re-champion it and dust off the old podcasting boots. So
right on. Very cool. Yeah, as we all know, podcasts are the rage right now. It's like microbrews, coffee roasting, podcasts, then Twitch and things like that also are pretty big. Have you looked into doing anything like that? Do you do anything with games or?
no, I mean, I am an old sort of console I mean, I say that, but I did play WoW for a while when I was younger. But nothing, I mean, you look now and the just caliber of gamers is so much higher than when I was
Yeah.
playing. I mean, I'm almost 38, and I feel like back when I mean, it just was night and day. So I leave that to the accomplished gamers and I'll stay
Right.
in the science field.
Very cool. Very cool. So if anyone follows you or now they're checking you out from just seeing our introduction, you're gnarly by nature on Instagram. Now, what's the story behind that? That was just one of my questions. Like, it's gnarly, obviously, but nature, because I really want to say gnarly by nature, and then
Of
you could be
course.
like, that's not how you say it. But what's the story behind your name there?
I wish I could say that there was a prolific backstory, but it's really just I thought I was being clever with a silent G, and I like naughty by nature,
Right, right.
hip hop group. And I didn't think that my science communication platform would take off in the way that it has. So I'm sort of stuck with that original name, and I don't want to change it because I think there's something so funny about that. People are like expecting to find me under like Leah Elson or Science Queen, and I'm like, nope, it's gnarly by nature.
Right on. Yeah, but it kind of sets people up for your style. I mean, that's what there's a lot of science and STEM infotainers out there, and they're all very cut and dry. They're A, B, C, D. It's almost like you're the first person to really have a personality that's more accessible. Like everybody loves Neil deGrasse Tyson. He's great, but he's very much this is this and this is this, and it's harder for a lot of people that maybe are wanting to know what STEM is and wanting to be more science literate to get into. So what made you kind of decide to have more of a loose format to it? It expresses your personality obviously pretty well, but do you think it's more of a benefit, or do you think it hurts you? Like you said, people maybe don't expect that really need to take you seriously.
I think that the biggest barrier currently to people pursuing, if not even a career in sciences, but just continuing to study science, which is so critical because we live in an era of science and technology. What really predicates people not wanting to pursue that and to kind of educate themselves is the inaccessibility. And a lot of that is the fault of my peers, right? Because we make science so subspecialized and a lot of the lecturing is top down, right? It is experts lecturing to what they think people need to hear. But really, I find the best generation of content from a scientist's perspective is understanding what they want to learn and doing it in a way that is very accessible. And I sort of pride myself on being the figure that is a scientist that doesn't look like it, right? I have a full sleeve of tattoos and I have a nose ring. And so you don't expect this. And I have received such great feedback from people saying, I love the fact that you are so accessible. And I failed on my science courses, but now I find myself seeking it out because I was drawn to your content. And I mean, I can think of no bigger compliment, to be honest, in this field.
Right, right. That's very cool. So leading into some of the questions here, obviously a lot of people want to know your background, like what drew you to science? Were you influenced by particular scientists or a particular field, or a particular, incident that you could name that's like, this is what kind of did it for me?
I think most people in the sciences, they have some sort of pressure cooker that they grow up in where a parent was a scientist or a doctor or something like that. I actually have no scientists in the family. and
Yeah.
like the college thing, my dad went to college, but he went to the Air Force Academy. So he just went to fly airplanes. So there's really not a lot of sort of like higher education in that capacity. Certainly none in science and medicine. And I was just always the Y kid. And I was quite bizarre growing up. I mean, I think most most kids were, you know, getting in their social circles, and in middle school, you know, they're starting to get boyfriends and girlfriends. And I was actually literally raising brine shrimp to study their morphologic changes as they developed, because I was just so curious. And so I was absolutely a very strange child.
Right.
I think
Sure.
my dad would argue that not much has changed. And I've just maintained this passion through the course of my life. And it's what drives me to be a full-time scientist today, and then sort of an off-hour science communicator at night, and, you know, an author and all of these things, because I just live and breathe the sciences. I think they're great.
Right on. Very cool. So do you have a favorite field of science? You do clinical development, education. People, again, watch you, see you teaching doctors how to do things. And obviously, a lot of questions we want to dive into are more like, you know, physics, astrophysics. Everybody wants to talk about things in the universe. Do you have one field that you really prefer talking, or is it all sciences that you sort of want to express to people?
I love all sciences. You know, I've been in upstream medical research for 14 years now. So obviously I love the human medicine and physiology component. But if you were to ask me, hey, if you were to do it again, what would you go into? And it would be like astrophysics or something.
Yeah.
I am enthralled by space. And I think a lot of that is reflected in the topicality. I always get really excited when I have the public vote. If you're unfamiliar with me, the followers will vote on sort of a larger topicality they would like me to cover. And you'll notice that I always kind of slide space in there. I'm like, come on, space.
Yeah, it's like a space one. Come on.
Yeah. And so I always get very excited. And surprisingly, some of my most popular videos are on what was completely unexpected to me, like quantum theory. I was like, this is not going to hit for anybody because it's so abstract, but I mean, it is still crushing it. It's got like 50,000 views or something.
Wow.
And I'm like, on quantum theory, that's wild.
Yeah, we've kind of delved into that in our last episode we did. I've always been curious about that. Like, I don't have any science background, but I'm way into sci-fi. And I think that's what triggers a lot of people to learn the real science of it, and also understand things like, you know, light speed, which people want to know about light speed. And then time travel. It's like, do these things tie into the universe and our practicality of every day? Like, you know, are we going to see people on other planets and alien stuff, you know?
Of course.
And it's very awesome to see someone that also has that vibe, but that is also super knowledgeable. Like, do you often get stumped? People ask you something, field of science you maybe aren't sure, or like, it seems like you know way more than any one person should know about all these different sciences. But how do you cover so many things and be confident, like, yeah, this is due? Like, I think you have a photographic memory or something. You almost have to at a certain point.
I think if I'm engaged in the material, it's certainly easier to remember. But if you guys are listening or seeing, I'm not sure how you're viewing this, but I have a rather large, I have like 50 square feet of books behind me. And a lot of that is space. A lot of it is physio. A lot of it is nonfiction. I love nonfiction when I'm reading. And I wouldn't say I have a photographic memory, but when I'm enthralled by something, it sticks around. And I sort of say that I know enough to get myself in trouble across all scientific fields. And I know enough, like if you were to put me in a room with an astrophysicist, I know enough to sort of get by in a conversation. Right. But if they wanted to like dive into the integrated calculus associated with one particular phenomenon, I'd be like, yeah, and I'm out.
Right.
But I could get by.
Yeah, you bait and switch them to one of your specialties. Like, well, let's talk about repairing human tissue now.
I'm like,
let's see how far you get with that.
About axonal regeneration. Let's talk about that.
You're supposed to do who now?
Yeah, exactly. Then
like, oh, it's time for lunch. Let's go.
Yeah, I was gonna say, or I just start eating really aggressively. So.
Right. And I guess pickles are one of your favorite things, apparently, from your last post there from the gym.
I'm a pickle fan. I once bought an entire box of just like individually packaged like carnival dill pickles, and it was like the best 3 weeks of my life. Several pickles a day, and I was like, this is probably not good for my esophagus, but it was wonderful. A lot of vinegar.
You know what? You got to say you did it and survived, so there you go.
So it is possible. N equals one.
Right. It's research for your next book. Like, how many pickles can I eat before I get sick and probably croak? 1 jar in 3 weeks. There's your answer.
Yeah, there you go.
Cool. Well, I'm really itching to get into some of these space questions. So you have a submission here right off the bat about galaxies. So one of your followers asked, is it true that galaxies travel faster than light? And aside to that we all know Einstein and his theory, you know, and how nothing can travel faster than light and this and that. What's your take on that? And are things like galaxies traveling faster than light? And is that something that we don't know how to explain faster than light based on current science? Like maybe 100 years from now, they'll determine a new equation. It's like, well, you can go faster than that. So is science always something that, well, this is a fact up until we prove it's different, and then we'll change after we find different answers to new questions?
Sure. So this question can be answered, and I think Einstein would be very proud, is that can you travel faster than light? It depends. It's relative. So within the vacuum of space, if you were to think of everything that we know of contained in sort of a bubble, the universe that we're familiar with, traveling through that bubble, you have a universal speed limit, and that is the speed of light. And it's like 300,000 meters per second squared. That's tremendously fast. And you can't travel faster than that within the bubble. Now, the interesting thing is that the bubble is not static. The bubble is expanding. And in fact, it's expanding at an accelerated rate. And so while you are limited to that 300,000, just under 300,000 meters per second squared within the bubble, if you're in the outer reaches of that bubble and the fabric with which you're traveling through is expanding at an accelerated rate, if you were an observer outside of that bubble, you'd be like, okay, these galaxies in these areas here are actually technically traveling faster than light when you take into totality the entire universe. But as we witness it within the bubble, relativistically, you cannot travel faster than that universal speed limit. Now, that is something that is clocked, it is known, but the question is, why is that the speed limit? And that might be something that we could unlock in the future. What is it about massless objects? And it has to be a massless object, right? If you have any kind of mass, if you're not a photon or quantized energy, then you can't actually travel at light speed.
Right.
That's a caveat to this. Because of something known as time dilation, and I think somebody asks about time dilation in further along in the questions.
Right.
But yeah, I would say relativistically, yes, technically some galaxies, if you take into account that they're also traveling on a walkway, it's sort of like those people movers at the airport. You can walk at one particular speed, and if you walk at the same speed on a people mover, you are in totality moving much faster, and that's sort of what's happening with some of these galaxies. So yes, technically you can.
Right. Awesome. So one of the things, oh, go ahead.
I want to clarify something here just because I'm curious. So is it that these things are moving faster than the speed of light, or is it our perception of them moving faster than the speed of light?
Right, exactly. It's sort of our relativistic perception. So when we're within the bubble, there is that speed limit, but because we're also in a space-time that is accelerating outward and growing and growing and growing every second, and it's doing so faster and faster and faster, technically we're suspended in something also moving. So you have to add those two velocities together, and then that could technically be faster than light speed.
Okay, interesting. Thank you.
Of course. It's a great question.
Right. And then you could also get into things maybe that are outside of our universe, and our laws of light speed and relativity and science don't even apply. Like, how do we know what might be out there?
Of course.
I do want to ask also, you talked about how our universe is expanding and getting faster. Now, I sort of read and understood that kind of goes against the laws of physics for something, because things like, take a bullet, for example. When you shoot a bullet, it immediately starts slowing down. Like, it doesn't keep increasing as far as it goes from its starting point to its destination. Is that true with our galaxy? Is in our universe? Is it not following principles that we kind of think are like, this is a standard for everything?
Sure. So the reason that a bullet would slow down upon being fired from a gun is due to air friction. So it has a slowing factor, an opposing force due to just the atmosphere around us. Now, obviously, when you're in the vacuum of space, that no longer applies. So you could shoot a bullet in space and it would travel at bullet speed until it encounters something that would, say, crash into it, et cetera, into perpetuity. It will just keep going.
Right. But it wouldn't speed up though, right? Like, our galaxy would maintain its like terminal velocity, I think is the word from the Charlie Sheen movie. I remember that.
So the velocity, again, this is a question of relativity. So if you are inside of our little bubble, we're all moving on something that is expanding outward, right? So we're all kind of seeing it relativistically. But if you were to measure the ultimate velocity of the galaxies, they are all moving away at a rapid and increasing pace because they are in a substance that is expanding and sort of an elastic substance expanding outwardly.
Wow.
And that's all driven. You may have heard about the term dark matter. The sort of expansion of the universe, we believe, is being driven by an entity known as dark energy. And so gravity is the thing that pulls everything together, and dark energy is what makes the universe expand outward.
Right. So it's an energy source basically that's powering the universe.
You could consider it like that. We're not really sure what it is. So much of astrophysics is we don't know what it is, but we can measure the way that it's working. We see what it's working. We put equations behind what we're witnessing, but oftentimes it takes a long time to be able to actually witness that. And something like dark energy, it may be something that is in a different dimension, a fifth, sixth dimension, that we just will never have the capacity to see with our very limited 3-dimensional viewpoint from our little rock where we are.
Right. One of the videos I saw, of course, Neil deGrasse Tyson, he's the king of kings for infotainment and STEM.
Fun fact, he actually has my book.
Does he?
He does. Yeah, it's
right
in his home office.
That is so cool. He was explaining our galaxy, how it's super thin. It's like almost like a sheet of paper. It's 100 times wider than it is deep, and how that really limits what we can see. We can only see like the north and south if you were looking at it flat, and we can't see east to west. So it's really, of course, now I'm seeing more videos like this because I'm searching science topics. So the AI algorithm is working, but this is perfect. It leads me to one of the other questions, and I sort of jump around as things tie together. So you've mentioned AI. What's your take on AI? Is it really a threat? Are people afraid of things just because Terminator, even though you have like, Bill Gates and Elon Musk and all these super up there in space kind of guys, pun intended, saying that it could be a real threat? But like scientifically, I don't see a lot of scientists saying this is or isn't a threat. Like, what's your take?
So I think that with respect to AI, the devil is really in the details. One of the most staunch, I would say, detractors of AI was actually Stephen Hawking. And Stephen Hawking said that the greatest threat to humanity is AI. It wouldn't be climate change. It wouldn't be something like that. It would be AI. Now, AI stands to really help with some of humans' greatest issues, right? How do you cure cancer? How do we stop global warming? These are questions that you need a lot of processing power for, and human machinery and, the human mind has sort of an upper limit. And so incorporating AI into some of these algorithmic structures can help us to solve these massive problems. Now, the problem is when you get something like ChatGPT and the developers are like, it's great, it's working really robustly, and we're not sure how. And that becomes problematic. But what I am encouraged by is that when ChatGPT kind of suddenly hit the market and was very instantaneously wildly successful, a bunch of the developers were like, whoa, we need to have a summit, and we need to kind of put some constraints around the development of this kind of technology, because then you start getting into moral implications, right? Like if you suddenly create an AI that does become sentient and self-aware, who is representing that AI? It needs to have some sort of legal representation. Does it need time off? Does it need paid vacation? Do you consider it a human entity? And so with respect to people's concerns, to actually get back to the core question, I think when people think of concern from AI, like you said, they're thinking of something like Terminator, where machines are just going to like take over and like wage war against humanity. And I don't think that that's not as much of an imminent threat as, say, something like a collapsing economy would be, because AI can take over so many industries, and that would put millions and millions of humans out of work, because you don't have to pay AI, you don't have to give it Insurance, you don't have to give it time off. It can work 24 hours a day, 7 days a week. And so we really are sort of in this interesting, we're like looking down into a precipice of like, okay, we want to incorporate AI, but then again, like what are the implications that that will have on the human labor force, right? So that is, I think, the most imminent threat to humanity right now is how many jobs will suddenly become defunct, and it would be sweeping if we really kind of let AI loose. So
Right, because as we know now in 2023, there's writers' strikes and actor strikes because AI is exactly what you said. It's like, well, I don't need this actor anymore because I can program it. So yeah, you're losing jobs, but you're also losing the artistic side, the creativity. Like AI can mimic something, like you put all this data in and say, well, make something like this, like make a song that maybe Beethoven would have written, or make a song that maybe Jack and Seven Spires had written, you know. But it doesn't have that soul, that artistic thing. I think the biggest threat would be if AI suddenly was sentient and it had a soul that you didn't have to put into it. And I'm saying soul is, I don't know what the scientific term, a conscious.
sure,
It would be a conscious, where you don't put any input into it and it just starts creating. It starts painting on its own. It starts writing poetry on its own. That for sure would be scary. But then you also have all the positive aspects that could come, especially with like quantum computing. I really got into this series called Devs on Hulu, and it's like a creepy horror sci-fi all wrapped into like a murder mystery kind of thing too. And it really triggered me to like learn more about computers, because I've always been into computers. I've programmed computers since I was a kid. I built computers, and of course the computer guy's computer always crashes, just like a mechanic's vehicle is always broken. But like I saw a company that's working on, it's like a dietitian, and they want to use AI to analyze your gut, your bacteria and things in your body, and to have algorithms say, these are the foods you really need to eat for your body. And it's different for every single person, even though we're made of the same stuff. We're all made of stars, just like garbage. But you know, the implications, like what you just said, it's like, well, how many dietitians that went to school, that got certified, that have a customer base, that all these things that they provide, you know, for their family and this and that. How many of those people are going to lose out if this algorithm is successful? One person will technically own it, you know, if it's patented or copywritten or trademarked. And then the economy, you know, I'm like really scared now just from what you said. It's like one little thing can crash so many other things in like a blink of an eye.
Of course. I mean, it would be essentially every single industry, you know, medicine, graphic arts, you know, everything. But that is, before everybody starts like doomsday prepping, listening to this, the thing that you should take heart in is that there have been several committees and international summits, et cetera, where everybody has begun to put sort of rules and constraints around the development and more importantly, I think the mobilization of AI with these things in mind, right? People are starting, economists, et cetera, are kind of trying to help balance the scales. And so these are things that I applaud us for doing, because I think so easily this could get out of hand. And there are so many AI apps, et cetera, that have cropped up just in the last month to 2 months. So it's good to see that somehow in some capacity brakes were put on human ingenuity, which you don't too often see in history.
Right. And then the only other side of that coin is the supervillain that doesn't care that there are rules, that doesn't care there are laws against these. There's always rule breakers. There's always law breakers. Look at how many people are incarcerated for various things. So it's like you have to have rules, you have to have enforcers for the rules, and then you have to have enforcers for the enforcers. So hopefully much greater minds, obviously, than myself are involved in these things and working as a group. So one person really can't have that much. I saw recently, I read today, like Elon Musk wants, he invented PayPal. For anyone that doesn't know that, he started with all these companies and buying and building and selling, and PayPal was a big one for him back in like 2000. And he initially wanted PayPal, it was called X beforehand, and he's kept that X nomenclature through today. But he wanted it to be like a financial empire, like global. Like he didn't want it to just be money transactions. He wants to be in control of everyone's finances, from investments, healthcare, loaning money like a bank. I read just today he doesn't want his employees to have bank accounts anymore. He's like, in 1 year, all ex-employees should be in the X financial universe. And to me, I like Elon Musk. Back before things got so crazy with him, I really admired him a lot. But how much can one person be control of? He's probably going to be the one that gets us to Mars. And I'd like to tie into that with you, is, as a scientist, why is Mars so important when there's crazy problems on Earth, like AI, what's going on with that? We don't have control, but all these resources and all this hype in the community, in the world, about getting to Mars seems a lot to me, with no one really saying, well, scientifically, like, this is how it'll benefit us on Earth, the pale blue dot, as Carl Sagan calls us. How do you view Mars, and what do you think is the primary driving goal? Like, why really would scientists want to be on Mars, like, so bad? Like, why is it so important?
So I think that there are a couple of different goals. There is sort of the infrastructure, physical goals that Mars sort of represents a possible spillover planet, right? There are certain things that human beings have either put into motion themselves, e.g. global warming, having a population that is continuing to grow unchecked, that our planet will not be able to sustain, because this growing population is also sapping natural resources, et cetera. And so the things that are human driven, Mars represents a possible planet for us to escape to if something gets completely ruined here. There are also the threats of massive natural disasters, right? We could have a large asteroid collide with Earth, and that would essentially drive us into a sixth extinction event, and Earth would be uninhabitable. There are also massive underground calderas in the in North America underneath Yellowstone, that if and when, it's not really an if, it is a when, a supervolcano goes off, it will be another sort of apocalyptic event, right? And so having a secondary planet would potentially help to save our and other species, right? It's a place we could escape to. But beyond just the physical outlet for Mars, traveling to Mars is also a really important beacon of philosophic underpinnings, because human beings have always thrived on the next greatest frontier, right? Evolutionarily, we all started sort of in the savannas and the plains in Africa, and we spread out, right? We moved northward into Scandinavia, over into China. We crossed the Bering Strait, came into North America. We conquered the seas. We made it into space. We are always a very, very curious species. And one of the greatest questions that we would want to answer as the only sentient species that we currently know of is, are we alone? And Mars represents this really beautiful possibility for that, because there are signs that there may still be liquid water on Mars, that there were certainly oceans and large lakes on Mars in the past. And this presence of liquid water, along with other factors on the surface of Mars, we could get there, we could get samples back and find that there are still microorganisms in that soil. And that would answer humanity's greatest question, is, are we alone? And I think questions like this, answering things like this, I think this helps to bring together what is currently a fractured species, right? We are fractured. I mean, you look at the wars over dogma, over territory, over race, over everything, languages that we speak. It's all very superfluous. We are very small in the grand scheme of the cosmos. But answering a question like that, like, hey, we are not alone, and we are unified by the fact that we are Earthlings, and we just found out that there's something living on Mars. There's like little creepy crawlies in the soil and in the caves on Mars. So that is a massive unifying factor that I think philosophically could help humanity to solve really big issues, because there are things that, fractured in the way that we will never be able to do unless we sort of come together. So
Right. Wow.
Yeah, I need to digest that for a second.
Yeah, very
everybody just got real sober right now. Oh my gosh.
like, wow, I should have had a beer before this or something. No, that's you know, I really like how you connect the dots. We've been so lucky to have people participate in our sessions with the questions. And the flow is like, I don't know if just more people have this, or we kind of have a sense of seeking out people that will probably fit our format. But like what you're talking about, the big scheme of things is people want to know if we're alone, is someone else out there. I read about this thing called the Fermi paradox. I don't know if you're familiar with that. It's basically like, there's so many planets, like there's so many galaxies, there's so much of this out there, but we haven't been contacted. We haven't had any interaction with any other creatures that we can tell. But from my understanding, like if you think about things, it's like what we perceive as life is focused just to elements of our planet, you know, liquid water, air, carbon, things, you know, nitrogen, the basics of all your life. How do we know if we send a rover to Mars? How do we know it just didn't land on a whole civilization that exists on Mars based on a life form that's not us? Like everyone wants to see an alien that's you know, looks like us, kind of stretched out, the grays, the big eyes and stuff. But we really don't know like what other elements could create a new life form or different life form. But the other thing I think about also, just based on what you said, is the size of the galaxy and the universe. That I want to say it's billions of galaxies inside our known universe, and the size and the massiveness. And you know, we talked about how things travel. Like you have to go light speed, which is, like you said, 300,000 feet per second or whatever. And it's also, I read, it's the coordinates of the pyramids. One of the longitudes or latitudes is the speed of light, which I don't know if you've ever heard that, but I can't find a hard answer that that's a fact or not.
I think that probably answers that question.
Well, you know, you have to ask the right people the right questions to obviously get the right answer, or to get a not stupid question answered to the right person. That leads me to think about, like, I'm interested in like wormholes and how there's the folding of space that's really got me interested. Of course, seeing things move that have mass at near light speed, that's all Hollywood, that's all science fiction. But perhaps technology existing that can take those billion light years on sides and just make them connect is an alternate thing. Do you know much about that? Can you sort of back up what I think might be a true kind of existing thing? Or
Sure. I mean, I think it's certainly possible. And we actually have several sensors that are in different positions on Earth's surface that measure gravity waves. And gravity waves are these ripples that occur in the fabric of space-time. And, you know, it's they're very small, usually by the time they get to us, thankfully, because these massively powerful events are happening quite far away. And you can think of it sort of as if you were to throw a pebble into a still pond, and you see sort of those irradiating ripples that move outward. And this is sort of what you could make analogous to ripples in the fabric of space-time, is sort of these little waves that occur. And we know that this exists. So we know that you can manipulate the fabric of space-time in some capacity. You can make it contract and shrink just like ripples on a pond. But the device that you would need would have to be so powerful to move and manipulate space-time in such a way that you could essentially conjoin different coordinates just by virtue of how much you've deformed space-time locally in that area to move through, let's say, millions of light years, right, across to the other side. It is theoretically, yes, absolutely. If you could do that, that would be a great method of travel. Now, when would we have the capacity to do this? I mean, you're talking thousands of years, unless somebody comes and intervenes and says, hey, let me hook you guys up because you're these little terrestrial kids, right? And you don't really have you're still walking with fossil fuel, and that's embarrassing. So let us help you out. And so, yeah, definitely theoretically something that you could do that would work, and or just like a wormhole, maybe these things are naturally occurring, we're not really sure. Some people postulate that black holes that suck everything in, they have a corresponding white hole which spits all of the stuff they sucked in out into something else, right? And there are some theories that our Big Bang was the product of a white hole opening up, and so we are basically the garbage chute from a black hole in some other universe that sort of spit us out into this one.
We're the Florida of the universe. You heard it here first.
Exactly.
Exactly. Sorry, I know you live in Florida, but
listen, I'm not from Florida, so I can absolutely
right on.
In a non-biased way substantiate that statement. And so, you know, it is possible, but our technology, I mean, ripples in space-time occur when you have like supermassive black holes merging together. You're talking massive celestial events that generate so much force. And so we would have to figure out how to generate that kind of force in a very small scale that's also not going to open up a black hole and just swallow up your spaceship, and you would just get crushed into an infinitesimal speck.
Yeah, the spaghettification, as it's called, is like, I have nightmares about that, and every time I eat spaghetti, it's like, this is what would happen in a black hole.
It's getting drawn out. Yeah, it's
insane.
It's creepy.
I saw recently they're finding more evidence of black holes, and I want to say they've sort of pinpointed energy in space and those waves reacting to what is probably the first identifiable one, because up until recently, and maybe past now still, I'm not sure, black holes were theories. Like, we didn't know for sure there was a black hole, or is that maybe I'm reading too much and not the right things? Like, do they actually exist? We have proof. And then as a side note, or the back end, like, what would you see if you were on the other side of a black hole? Like, do we know, like, is that where that white hole might be on the back side, or is it like a mirror on both sides where it's a black hole? I'm curious if we know the answer to that question.
Sure. So the strange thing to stretch our minds around is that when we say the word hole here, you know, we're thinking of sort of like a two-dimensional object, right? You're looking at like a sewer hole on the ground, you know what I mean? And you go down inside of it. So you would assume there's sort of like two planes of existence. There's you looking down into it, and then there's you inside of it, kind of looking up, and possibly a backside. The black holes are spherical in nature, at least the way that we perceive them. So they're sort of, it's like a big ball sort of sucking things in from all areas, right? And so there's not really a backside, but you wouldn't see the black hole itself. The black hole warps space-time so significantly that light can't even escape. So traditionally, historically, we hadn't been able to see them, and the only time you can really see where they are when they are actively eating something, because they are stretching these things out. They're, you know, they've got like a lot of radiation in that general area, and you can image them. And actually, for the first time, I believe in 2021, we imaged a black hole for the very first time eating something. And so we got our very first photographic proof. And then they were able to clarify that image. And the beautiful thing, and if you're listening to this, I highly suggest you look it up, like image of a black hole. They were able to get such clarity on it that you can actually see the gravity waves sort of, and it looks not unlike when you flush your toilet and you can kind of see things spiraling around it. It's this very beautiful toilet flushy kind of spiral pattern, but that's the warpage of space-time. And so you know, historically, black holes were theoretical, and then we were like, okay, we really honestly think, based on the motion of galaxies, that most galaxies have a supermassive black hole at the center. And this was actually confirmed for the Milky Way. We were able to confirm that within the last 5 years or so. Our supermassive black hole in the middle of our galaxy is called Sagittarius A star. So that was confirmed within the last 5 years. And then we got our first actual image of one eating something. And you can see like the perfect round disk from our perspective in the middle of that black hole where there's no light escaping, but everything on the outside, you can kind of see things being torn apart and circling into that void.
Wow. And is it true that to the best of our knowledge, that the time dilation thing really happens as you get closer to a black hole? For people that don't know, you can watch Interstellar and learn about it, kind of like I did. It's basically like as you approach light speed, you age differently from people that are, say, back on Earth. And in theory, what I've read and come to understand is because a black hole is so powerful and it has the warping of space-time, like you said, that you also get that same effect of if you're X amount of light years closer, you're aging much slower than someone that's farther away. Is that right?
Yeah, that's a good way to put it. So time dilation, you're absolutely right, it is a product of, it's actually funny enough to connect it back to the beginning. It's a product of light speed being constant. And time dilation is all a part of Einstein's theories of special relativity and general relativity. And it works in two different ways. And it's important for the listeners to understand that when we think of time, we think of something that's sort of abstract, right? I'm wearing a watch right now. It happens to be a calculator watch. Shout out Casio. We think of time as just numbers on a dial, but time is actually a coordinate. It is a fourth tangible dimension, right? So if I say, hey, I want you to meet me, on the corner of 6th and 20th at the, I don't know, MasterCard building. I'm giving you, 6th and 20th. That's like a northwest, southeast coordinate. And obviously there's an up down there. There's a third dimension. I want you to meet me on the 12th floor. You'd be like, great, cool. I'll meet you 6th and 20th, 12th floor, MasterCard building. Got it. But there is a dimensionality of that's missing because I never told you what time to be there.
Right.
Time is a coordinate. So I would say 3 p.m. we would meet at the exact same time right there. And we would have coffee. So time is actually an entity. It's a dimension, but time is also relative. And that's something that is a little bit mind bendy. It's relative in the exact same way that something like motion or velocity is relative, right? If you're standing on a sidewalk and you see a car drive towards you at 60 miles an hour, you're saying, okay, that is approaching me at 60 miles an hour. But if you are in a car that's driving 60 miles per hour towards another car that's driving at you 60 miles per hour, your combined velocity towards each other is 120 miles per hour. And that is a relative thing. Time acts a lot like that. And so when you put the time dimension into a gravitational field, so something like near a black hole, time actually slows down relative to that entity in that gravitational field. So for those of you who have seen Interstellar, you know that they get close to a planet that is next to a black hole. And so for them, time has slowed very far down. And I think in the movie, they're there for a couple of hours, and on planet Earth, they've lost like 30 years or something like that. And that is actually a very real phenomenon. And it is so real, in fact, that we actually account for it in our satellites, because on Earth, we are closer to a gravitational field by virtue of being closer to the surface of our planet. And so we actually, our time is a little bit sped up here. It's by fractions of a second. But the reason that GPS works the way that it does is because we account for time dilation by adjusting for it mathematically in our satellites, which are obviously miles above us. So they are living a life that is a little bit slower than we are. And I think they're slower by like, it's something minuscule. It's like, don't quote me on this, but it's like, 0.04% of a second. It's tiny, but it's enough that over time that would stack up, and our GPS would be completely nuts. It would not be accurate at all. So not only is time dilation real, but we use time dilation every day to account for satellite distance.
That's very cool. I saw I follow ISS, the International Space Station. I love the notifications where it's like, look up in the sky, it's going over top of you. And they did the same thing. The astronauts that are on the space station are aging slower, just like you said, because they're farther away from the core, the intensity of our gravity. It's crazy. Like, we think we're this little teeny tiny pinpoint in time and space, which we are, but we know so much comparatively speaking to what like they knew did they know this like 10 years ago even, that there was that
Sure.
much of a change with distance?
Well,
Uh,
what blows my mind is that, so much of the science that we use today in the era of science and technology is predicated on theories that were constructed. I mean, Einstein is, he was from, 20s, 30s, 40s,
right,
making things that we use today. I mean, special relativity, et cetera. And they did not have the equipment or the wherewithal to confirm it. And he was like, no, trust me, guys, this is the way it is. And it is.
right,
It is. And we're using it today. And even
yeah,
crazier, if you think back a couple of hundred years to Sir Isaac Newton, who first conceptualized the possibility of a force called gravity, and who came up with all of our equations for kinematic motion and the way that things move. Those same mathematical equations we use today in a very real way in astrophysics, etc. We use Newton's equation. So it's like all this very old math that we use to power the things and the rockets and everything that we use today.
right. Um, that's all great. That being said, it just sparks something to my imagination is, are there scientists in the field that are working to create advancements on these? Like, we're using theories that are 100 years old. We're using equations that are 500 years old. Like, how accurate are those as far as, well, this is everything, we can't learn any more about this? Or are they just waypoints in time where we don't know how to measure certain things? I love seeing pictures of like a huge chalkboard where the professor, or the scientist is working things, and there's all these things, and it looks like hieroglyphics, really, of course, to most
Mhm.
people. And you're just like, oh yeah, I know what all this is. And then the thing at the end here is always what you want to figure out.
Yeah, it gives me
Um,
PTSD seeing stuff like that.
right, right. But do you like, are there people maybe that are like, Einstein's theory is cool, but we're 100 years or plus past that. Just like Nikola Tesla, if anyone's into science and just amazing people, like, he invented free wireless energy 100 years ago, and we don't even implement that yet.
Mhm, mhm.
And just for scientific information, his wealth of knowledge is crazy stuff that he knew 100 years ago, with frequencies and vibrations and the math behind stuff. Just like you said, it's like, I can't prove this just yet, but it's real. Do you think some of that? Now, I've read that he thought these things came to him in like dreams. So it was a real metaphysical, not your five senses triggering thought. Um, do you know much about Tesla personally? Like, what's your thoughts? And also, are there people working on these algorithms and equations that are like, we need to move forward from this? Like, 100 years is cool, but like, let's next level this stuff, like, legit.
Yeah, Tesla was, I would say that every 100 years or so, you have sort of an actual genius mind. And Tesla was one of those people. And so much of the things that he developed, I mean, he developed alternating current, which we use in every single home everywhere across the nation, and across the world. He was so brilliant. All of the things that he said and conceptualized, etc., amazing. He also a very weird character. He shunned women, which I don't disagree with, but he said women are a distraction to my science. And so he never married, he never had a girlfriend, he never had anything like that. Shunned women completely, and fell into romantic love, and this is a true story, with a pigeon. He was
Oh,
renting a small space, like a hotel room space, and he sort of like trained a wild pigeon. He would like give breadcrumbs to this pigeon, and he wrote very extensively in his journal about this pigeon, and that he thought, and it would come into his room every day, and he was like in a romantic relationship with this pigeon and loved it like a significant other. And then one day the pigeon like came into his room, and he writes about it, and he could tell that it was like not doing well, and it sort of like flopped around a little bit and died in his room. And he was so brokenhearted about it that he actually died a couple of weeks later after this
wow.
like the love of his life, this pigeon died. So very interesting dude in all capacities. um but are there mathematics that we are still seeking? Absolutely, yes. So one of the biggest issues that we currently have are that we have physics that explain and will continue to explain the things that we can observe in the very large scheme. So the way that planets move, the way that galaxies move, when I throw a baseball, things like that, like the macro scale physics we can currently explain with our equations. And then we have a completely different set of physics that occurs at the subatomic level. Suddenly, the things that we know, the intuitive physics is what I would call it, throwing a baseball, driving a car, seeing a planet rotate and orbit around the sun, that does not apply on the very, very small. And everybody who doesn't know that, you need to get very comfortable with that fact. So, as a for instance, this is one of my biggest science communication videos is on quantum theory. But if I were to tell you to drive in a car, get in your car right now, drive 30 miles per hour for 5 minutes, I could tell you exactly where you're going to be in 5 minutes because I know you're traveling 30 miles an hour. I told you the direction to go, and I can just calculate that distance. Very easy. That's macro scale physics. Now, on the subatomic particle level, if I were to say, okay, cool, get in your quantum car and go 30 miles an hour and drive for 5 minutes, I would not be able to tell you where you would end up. I would only be able to give you a probability cloud. And it's not until you stop and I observe where you are that probability cloud basically collapses down, and I'd be like, oh, okay, you're there. But I mean, you could be in the same trajectory. You could be in a tree. You could be in your neighbor's refrigerator. Like, you could be in this massive cloud anywhere. And it's not until I observe where you are that I see where you are. There's not like a set predictability. It's a probability. And there's different physics that apply to that. You cannot take the equations we use to throw a baseball and to track stars and everything and apply that on that level. Now, the issue is not that these are different physics. The issue is that there is no unifier between them, right? There's no handshake between them. Right now, they may as well be different worlds. But the problem with that is that if we can't use our physical equations to describe everything around us, then there is something wrong. There is something missing. And this makes physicists very uncomfortable because if we can't find something to unify one equation, we call it the unifying equation. If we can't find the unifying equation to marry the very big with the very small, then we may have to take everything back to the drawing board, and all of the physics and everything that we predicated our science and technology upon for the last several hundred years basically means nothing. And it's just our best guess. And so that makes everyone very, very nervous. So there are entire teams, and of course now AI integrated into trying to help solve this question, is like, what is going on subatomically? Why is it so different? And how do we marry those maths with these maths over here? And until we do that, everything may as well be wrong.
Right. So what we think is true and correct only applies to our time dimension, based on, I guess, us observing it. I learned about how I love quantum entanglement when I first started learning about things on the subatomic level, how they interact, and they don't follow what we consider laws of physics. And it's the observation part that just blows my mind. I'm sure that's the same as everyone else that learns about this, where particles do or do not do something, and it changes when they're physically observed by a scientist or by someone running an experiment. It's almost like the missing element, I'll tell you right now, it's consciousness. That all of these vibrating entities, photons, electrons, neutrons, quarks, all as you go smaller and smaller, they've got to have consciousness to be observed and act differently. And I watch every single video and I read everything I can find that people doing experiments, and there is zero proof of experiments that I've seen of these things not acting differently when they're observed. So 100% of the experiments, particles on a subatomic level act only a certain way when you're watching them, like when they're supposed to. And that's just like, wow. Well, yeah. How do you explain that to people? And how do you put that in like layman's terms of, yeah, there might be shit going on that you don't want to hear, might scare you, but we can't explain it. Like I read that they don't know, like everyone knows what gravity is and its effects, but they don't know why it happens the way it does. Is that true? Like we don't really know why it happens, but we can observe its effects.
Yeah, of course, we can observe its effects. We can calculate it incredibly accurately, but we don't know what it is. We don't know the leading theory. I say leading theory, there are several, but one of the leading theories right now is that it acts through quantized things, just like light light energy is carried via photons, right? Things like that. That there is a particle for gravity called gravitons, that somehow is linked in this connection. The thing that Einstein said was that very massive objects bend space-time to a very large degree, and it's almost like making like a massive funnel. So if you and your friends were to hold out an outstretched sheet and then toss a bowling ball into the middle, it would warp that sheet downward, and that sheet is basically space-time, and that bowling ball is like a massive object, right? And so then if you were to kind of toss smaller like little marbles in there, those marbles would be drawn down into that funnel, right? That funnel of space-time, and that could be, you know, a black hole, or that could be the sun kind of raining in planets, etc. Versus if you were to outstretch that sheet and just throw one marble in there, right, you're not really going to get a lot of deformation of that space-time or of that sheet. And so you could try to pop other marbles around it, but they may not coalesce in the same way as if you had something very massive. And so that's one of the things that Einstein said. He said, and that is what general relativity is at its core. It is explaining that massive objects warp space-time to such a degree that they sort of, this is how you get large orbiting bodies and solar systems, et cetera, to kind of coalesce and come together.
Right. Now, does that apply to all things in scale? So, for example, you take the size of our planet and the gravity it creates for us being on its surface. Are there particles like on my body right now that are the same scale, smallness that I have? Am I emanating gravity to other particles the same way the Earth does? Is that
absolutely
right?
You are,
wow.
Yeah, you are actually imparting gravity to Earth. So you are pulling up as gravity is pulling you down. Now, obviously the Earth is pulling you down many magnitudes higher than you are, which is why you're not kind of like sucking the Earth up into you. But yeah, no, everything, and even, you know, the Earth, it's very staggering to think about, but the Earth was created after, you know, the wake of a massive stellar explosion, right? So there was a supernova somewhere in this vicinity where we are in the Milky Way that exploded. A star just exploded, and it blew out, you know, star guts, which is like dusts and gases. And during that explosion, you know, hydrogen fused to helium, fused to lithium, fused to all these heavier elements. Then it just became sort of this ethereal gas in this area with like maybe, you know, more dense areas in between. But gravity is so powerful that in every single celestial formation, galaxies, every, you know, star system and planets that you see, this is all the coalescence of tiny particles over billions of years that come together. So you'll have like individual gas atoms that will come together and collect, and then you'll have maybe a little tiny chunk of space rock that will come in, and then a larger one, and they'll all kind of come in. We call this accretion, when things start, larger things to slam together. But even Earth, you know, it didn't start as a massive body. It started as like little specks of gas and dust that sort of coalesced over time just because of gravity.
Wow. Good stuff. Those are all also possible band names, all these scientific terms you have.
Oh, I talk about that all the time, like gravitational coalescence, you know,
graviton.
Like, yeah, 100%.
There's a band in Boston named Graviton, actually.
Is there? Oh, there you go.
I always ask a friend of mine, he's, you know, we actually know him together. His Mike Presley. Shout out Mike, if you're listening to this. I always will send him random scientific terminology and be like, tell me what genre of band this would be. And he's very specific. He'll be like, oh, you know, that's like 1980s New York hardcore, you know. So
it's like
funny.
nouveau synthetic artcore with a hint of straight edge.
to bring in like a little bit of the music scene. So
Mike, for sure.
Mike was living with me for a little bit of time, and he actually filmed me. He had me read Cannibal Corpse lyrics and explain what all the terminology meant. And so it was me just interpreting Cannibal Corpse from like a medical standpoint.
Yeah. Well, if you didn't know, we all simultaneously were in the same universe about 2 years ago, because in a nutshell, the way I knew Mike is he's couple with a friend of mine that's vegan, worked in an animal shelter where I was a volunteer. So I just put a word out. I needed to send some product, some coffee, because we do coffee for Jack's band. I needed it to go to like Tampa or whatever. And my friend's like, yeah, my boyfriend's, he's down there. What do you need? I was like, I just need to send this. He gets to go to a show. Jack's band was playing with Dragon Force. They did a huge tour 1.5 years, 2 years ago. Very cool. So at the same time that Mike was living with you guys, he had our coffee and went to the show and gave it to Jack's crew, his merch girl, so they would have it for the tour. So circling back, like I didn't know any of that. I hadn't talked to Mike for almost close to a year. He got social media, and God bless him for being able to do that. I'm like, I wish there was some way I could push a button and be like, I can still survive and businesses run and everything with no social media. But I'd shared a post on my page, and I want to say his girlfriend Jen, shout out to Jen. She's like, hey, check this out. He's doing a podcast and Leah's on it. And and I told you, I was like, hey, I just got this crazy message from my friend Mike, and he's sending me all these pictures. I'm like, dude, that is so insane. Like the circles are so small, even
Small world.
700-800 miles away. If it's a cool science thing, it's a metal thing. I know he was real big, like muscle head and into fitness, and you, among other things, are a power lifter, and hopefully we'll have time to drop into that and hear some experience there. But it's just so crazy how things are really small when you don't think they're connected at all.
Very small world.
But on that note, hey, here's a great segue to how can you also be a power lifter? You're an advocate for pit bulls. I think you kind of gave me your spiel. I was like, so what's up? What's your deal? Like, how do you find time for all these things? And how does that play? Like, do you cheat because you know the physics of this is how I build muscle mass? I'm not going to use roids. I want to eat this thing and combine these macros and nutrients. Like, what's the secret for like your fitness and being a power lifter, which is not something that a lot of females, let's be honest, get into powerlifting. What's your connection to that whole fitness world?
Sure. So I had been an athlete since I was quite young. I always liked sports. I was a tomboy, and I played through college. And when I got done with college, I was like, man, what do I do with my life? Because I've been like a student and an athlete my whole life. And then you take away this large part of your identity and you sort of wander around like, I'm not really sure what I do. And so I kind of came into lifting. I had a few friends that were lifting, and I had lifted, as part of training. It had never been a main focus, but when you're in varsity in high school and you're playing at a collegiate level, you weight train. And I really liked it. And the interesting thing is that I could apply the physiology that I can understand from the human medicine side of things, and apply it to like, what are my goals, right? And for instance, people, I think there's this thing that has been peddled upon people where it's like, oh, if you want to lose weight, you got to do a lot of cardio. But really, cardio is great for your heart, and it's great for you to sort of like burn calories in the moment. But physiologically, your fat burning combustible machine is your muscle mass. And so I always tell women, like, lift really heavy. You're not going to get big unless you're on a bunch of juice and you're doing a bunch of steroids. You can't get big. You don't have the endocrine cocktail, but build a ton of muscle, because physiologically, muscle needs, it's a catabolic engine, and you will burn fat as you sit on the couch on your off day if you have a large amount of muscle mass. So I think a lot of staying healthy, et cetera, is one, it is a good escape from being so cerebral all the time, because like I said, I'm a full-time scientist in biotech, and then on my off hours, I'm doing science communication, writing books, et cetera. And so it's like my off switch. I can just turn on metal and like go to the gym, and I don't have to think about science, and I can just lift. And I lifted before this, actually. It was bench day. But it helps, it does help with the pursuit and understanding, muscle breakdown and how long it takes to rebuild, and sort of the things you need to intake and eat to sort of maintain healthy muscle mass and body composition. So it is a bit like a cheat code, definitely.
Right, for sure. Now, I'm glad you brought up some more metal ideas and connectivity. Do you have a go-to? Like, what do you listen to really for the gym? I'm probably able to guess a few things, but also does metal also bleed over into your science? Like I know you do a lot of things where you're dealing with small human anatomy that you're weaving things into. Do you listen to music? Like, is there something that drives you for the science stuff as well?
When I'm listening to music, the problem with me is that I am very distractible. And I think at 30, I'm almost 38. I think at 38 years old, I realized like I might actually have a little bit of attention deficit disorder type things in me. And I just thought I was just quirky. And then I actually sit down like with adults and I'm like, oh no, I might actually have something diagnosable. So if I hear music with lyrics, it has a tendency like I'll start fading into that. I'm like, ooh, I really like the song. So if I'm writing or studying or, you know, researching things, I have to listen to something a bit more melodic that does not have lyrics, or at least that's the good thing about metal. Most times you can't, especially really, really like dark metal, you can't understand what they're saying. But you know, I definitely use it for like PRs and things like Lorna Shore. I love for like really big lifts. But today, I mean, I can tell you what was on my mix today when I was benching. I listened to Wage War, I Prevail, Spirit Box came on, even though I don't listen to it a ton. Bad Omens, Motionless in White, Trivium, Upon a Burning Body, you know, things like that. So that's sort of like that's been on my lineup as of late.
Right on. Speaking of something you said earlier with deciphering lyrics with Cannibal Corpse, I have to send you some Carcass because the first 3 or 4 Carcass albums are all medical terms. They use like Grey's Anatomy and like are describing like medical procedures and all kinds of stuff like that. I'd like to get your perspective. I'll maybe send you a couple sheets and be like, does this make any sense? Or it'd be like me doing Chat GPT and entering well, translate this into German and it just spits out a bunch of words.
You know what might be funny, because I do have a decent amount of people who listen to metal who follow me as well. I should do a Real Science where I just interpret, you know, like Carcass or Cannibal Corpse lyrics like on camera. I think that would be very funny.
Yeah, that'd be great. Shoot me a message. I'll follow you when we do that, because that would be awesome.
Definitely.
I'm always big on lyrics and I want to know what they're talking about,
what they're saying.
But yeah, no, Carcass, I was like, what is all this? And of course you Google it, and well, back in the day you didn't have Google. It was like magazines, like back, you know, 90s, when some of these albums, they have an album called Necroticism Descanting the Insalubrious. I'm like, that sounds like a thing. It could be, I don't know, but it's all this graphic. And they moved away from that as time, you know, there's only so many ways you can describe like open heart surgery or cauterizing a wound. But they also got me, those guys were vegetarians for a while and went into veganism stuff, but they got me into that. Like they started doing more lyric, you know, talking about the horrors of like animal agriculture and stuff. And it's like they can write the most brutal, gory, disgusting thing about people, but they're like in actuality super really nice and, you know, don't want any harm to come to animals and stuff like that.
Sure.
So it was that juxtaposition of like these two things coexisting. Just like Corpse Grinder, George from Cannibal Corpse, we talked about this in another show. You know, he does all these special things for kids and like collects toys from like the claw machines, and he goes to like children's hospitals. But then, I mean, he also they have songs called I Come Blood. So, you know,
it's an interesting duality.
You know what? It works apparently. So there you go. Jack, you there?
Yeah.
When is there going to be a Spires album that's more scientifically talking about the universe? Because
that would be pretty fun, actually. I mean, we've talked about all sorts of stuff. I mean, we're not like a brutal death metal band or anything like that. So everything tends to not yet. Yeah, there's it's more emotionally brutal.
Yeah. There's definitely heavy elements. Like Leah, if you haven't heard Seven Spires, they have elements of like the bands you listen to, but tons of symphonic stuff. Then they also have songs that are melodic piano, single voice, kind of like I told them before. I'm like, I can't believe this is the same band in the same album that releases all of these different things together. Is really awesome. But
I love that. I love an album where you're like, is this the same band in the same album? That always impresses me so much.
Right. And it sounds like 80 people creating this music and like 10 singers. And nope, it's just 4 people doing the thing and making it amazing. So had to give a shout out. We're talking music. We got to go there.
Shout out. We got to.
Go follow Seven Spires. There's going to be tours next year. Everybody get on board now. They're going to sell out fast.
Woohoo.
Very cool. Very cool. So one of the things we could also tie in to get back a little bit to questions is I'm also curious as well is naming things. Like who names these elements? Who names, like someone asked, like who named a proton? Who named electrons? Like is there a society, like secret people like underground in a bunker somewhere coming up with stuff, or what's like the process? Like if you discovered a new thing, or like the God particle that they're you read everything about here lately,
The Higgs
like
boson. Yeah.
right. Well, obviously their names named it, but if it's not the people that discovered it, like what's that process look like?
Sure. Typically it's the teams, you know, it's the teams that discover it, or if there is a person who discovers it. With subatomic particles, a little bit, you know, a lot of them are descriptive, like a proton is a positively charged subatomic particle, right? So there's a proton. A neutron is neutrally charged. So, you know, some of it is intuitive, but there's actually this really fascinating history with the periodic table of elements. And there was sort of this like scientific schoolyard beef, right? Where like science dorks are not going to like go into fisticuffs and punch each other, but what they will do is they will try to discover things before their like worst enemies do, and then they'll name it. So like for instance, it's intrinsically tied to like the world wars, right? So like German scientists and American scientists and Russian scientists, they were all trying to find, there were holes in the periodic table. We developed it, and then we were like, okay, well, we know this element exists and this element exists, which means that there are two elements missing in the middle. And so it was this scramble for these chemists all over the world to find these missing elements. And if you found an element, you discovered an element, like it was this huge deal. You're like, oh, I discovered an element, I get to name it, and it's awesome. And it used to be people named it after themselves, but these different countries of scientists, they started posturing for the rest of the world, and they'd be like, oh, well, Germany discovered this one first, and this was like when we were beefing as a world, and so they would name it after like a German town, and then America would be like, yeah, well, we're going to call this like Americium, you know, like this is an American element. And it's very funny because it's like this very nerdy beef. Just if you look at, like, you'll see it, there's like heavier elements are on the bottom of the table. And if you're listening to this, pull up a periodic table and look at some of those heavier elements, and they have really wonky names, or you're like, that sounds like that could be a town in France. And it is. It's because they were all just trying to posture in front of each other because the world was like waiting for them to finish the periodic table. And it was like a weird political thing.
Right on. I mean, I'd love to see a Danzig particle or Danzig element somewhere, you know, from Austria. That would be very cool, you know.
Mother.
Yeah, it's the mother particle, they call it.
Exactly.
As far as the periodic table, like, is it done, or is there way more stuff we just don't know yet?
So the problem with discovering heavier and heavier elements is that those atoms are not very stable. So they will blow apart. And so many of the heavier and heavier elements that have been discovered somewhat recently, they are elements for like a fraction of time before they break apart and they become something smaller, right?
Wow.
And maybe people don't know this intrinsically. I feel like there are certain kind of like hard facts that no one really talks about, but elements, they can when they degrade, right, or like radioactive elements, they don't just kind of break apart and disappear, they become lighter elements, right? So helium, the atom helium, it is actually basically two hydrogen atoms stuck together, because hydrogen is has one proton each, and helium has two protons each. So if you take two hydrogens and you fuse it together, that becomes helium. And if you take, you know, helium and a hydrogen and put them together, that has three protons, that's now lithium. So all of these things, they kind of degrade into each other, or they build into each other, and you can take two heavy elements and smash them together and add all of their protons, and you're like, great, I made a new element. But if it doesn't stick around for a certain period of time, that's technically cheating, right? It has to stay around and stay stable for and it can be a fraction of a second, but it has to be stable. So the question is do other elements exist? And the answer is probably, possibly, but it would have to be in such extreme environmental conditions. So like maybe on the inside of a mega big star that, you know, is at the end of its cycle and it is smashing such heavy things together, because to overcome the repulsive forces that atoms have together, you have to have, I mean, staggering force. And that is only found in very exotic areas in the universe. So do they exist? Probably yes, but it would be pretty rare. Like we're getting kind of to the end of what we can find in a stable capacity now. So
Right. And the tools that we have can only measure certain things as well.
exactly. And we
so-
can only make things with as much, like, you know, like I said, a lot of our stuff still runs on fossil fuels and combustion. So we don't have enough force to make things in labs. So
Right. Now, I've always wondered how like water, like hydrogen, like two hydrogens and oxygen are both gases. How can it make water from gas? Like that is so insane. Like what's the, and I mean, this may be like elementary school knowledge, but
no,
like,
it's a great question. So all matter is exactly the same stuff. So like, you know, like you were saying, oxygen and hydrogen in the air, and there's actually gaseous water, right? There's like water vapor
right,
in the
steam,
air.
sure.
Yeah, exactly. So it's all the same stuff. There's solid water, right? There's ice. All of it is the same. It's just how much energy and how fast is it going. So gas is traveling zippy fast. It's like doo, 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 right? So you can have like hydrogen, for instance. You can have hydrogen zipping around as a gas. If you slow hydrogen down enough, it will become a liquid. You can put, if you like take some of the energy out, yeah, it will become like a puddle
So
of hydrogen.
the vibration as it slows, so ice is vibrating slower than gas.
Yeah, way slower. Yeah.
Wow.
And technically, I mean, if you could take out enough energy out of really any element, you could turn it into a solid, right? It's just matter is matter. It's just what is the energetic state that it's in. And that's it.
Wow. That's so awesome. Well, thank you for making it like the light bulb going off in my head. And
yeah, and it's a very good question because it seems so counterintuitive. We would think that these are different things. So I mean, it was a great, you know what, I'm going to add that if I don't already have it in a list somewhere, I'm going to add it to the next volume of There Are No Stupid Questions.
Yeah, awesome. And I'm also going to I'm going to sample you going zoo, 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 zoo. That's going to pop up on its own as well. And I will tell you, people are going to be watching this. This will be a video. So all of our goofiness and, you know,
fabulous.
All of these looks, yeah, it all goes on the YouTube so people can see us. And we're not AI. We're like, you know, HI, we're human intelligence.
I'm now embarrassed for having been picking my nose this entire time. So,
oh, that's okay. We'll just like cover that up with something a little later.
Fix it in post.
Yeah,
Thanks,
exactly. We'll make like a banana going into your nose and like a monkey in the background dancing around.
We'll just add a sensor bar.
Exactly. Everyone's like, is she swearing? And they're like, no, she's just picking her nose the whole time.
Hey, we always try to keep PG-13. We haven't had any swears, have we, Jack?
No, but you did say some Cannibal Corpse lyrics. So.
Which might be a little bit above the age of 13, depending upon the 13-year-old.
Well, we usually have one F-bomb, but we've never had a guest not swear, I don't think. So that's pretty amazing. So congratulations. We'll have to
thank you
a banana sticker or a little gold star. You can like, you know.
Which is actually interesting for me because like in my home life, I swear like a sailor. So I'm actually impressed by me as well.
Right. Well, I mean, I'd imagine you switch when it's like, okay, I have to at least be semi-professional, especially something that's going to be rebroadcast or shared out to the world.
Of course.
It's probably subconscious that you're like, I really, really want to scratch my neck right now. I'm going to try not to do it. And then it's like,
exactly. Yeah. Now that I know I haven't said anything, like it's gonna be like eating away at me. I'm like, oh, just drop an F-bomb. Yeah.
Yeah. We'll see. I don't know. We're covering a lot of stuff fast, and I like that it's connecting like organically. Like that's really important to me because, you know, you can tell when things are like 10 sections of like dead silence of okay, next thing on the deal. But you know, how long have you been I know you're not big on being an influencer, but a STEM magnate like yourself, or conglomerate entertainer, science entertainer. Like how long have you been doing this, and how long did it take you before you were really confident? Like you're talking to two metal dudes randomly on a Saturday instead of going out partying or something for Halloween, which happy Halloween, everybody. You'll hopefully be seeing this really soon around Halloween. But yeah, what do you think about that?
I've been doing this publicly for 6 years. But a little known fact about me is that before I went into science professionally early in my college career, I mean, freshman, sophomore year of college, I was actually sportscasting. So I've been in front of camera for quite a while, and I never had any formal training. I'm just kind of a ham in front of the camera, and I have the gift of gab. And when I'm passionate about something, that those kind of things kind of coalesce together.
Right.
And so direct to camera for me is it's second nature. So
Right on. Yeah. Well, for all the kids out there and adults that act like children, that's how you make Leah Elson Element. You take a little ham, you take a little sports knowledge, you take a
exactly,
love of being in front of the camera,
and a
um,
whole lot of science,
a whole lot of
and
science, and occasionally
there you
picking
go.
your nose when you don't realize you're on camera, and you're good to
Boom.
go. All
some
the
question,
elements.
some questionably undiagnosed ADD done.
Right. Well, I guess that's why there's so many, and also this under your credentials. Do you see a stopping point for yourself? Like, I know learning is something, it's like an addiction, like lifting weights or a drug. But like, do you think you have enough like of the book? Like, these are the things I'm sticking with, or is the ADD going to be like, well, I'm going to keep adding more letters to the end of my name? So you ever get a plaque or you get a sign on your door, it's just going to be like 300
Sure.
letters across.
You know, I think the fact that I'm in so much student debt, I would like to say like, yeah, I'm probably done. But you know, the reality, a lot of people, and I'm always very raw about this, they say like, you know, you do so many things. That's so extraordinary. You're so inspirational. And I'm like, no, guys, it's pathologic. Like, this is not a healthy thing. A lot of it is just sort of you know, an imposter syndrome that's driving it. I'm also very open about the fact that I grew up in a very tumultuous household. And so I was given sort of like the antithesis of support, if you will. You know, it was like sort of abusive, et cetera. And so a lot of the desire to excel and to continue to do more is a product of that. So it's sort of been like a fanciful product of that, where it's like, no, I want to do more. I want to prove that I'm worth something, right? And so there's been this litany of schools and like the book, et cetera. And it's a labor of love. I enjoy it very much. And you know, I could have been a statistic, but instead I chose to be a dork and go into academics. So I think if you're going to be addicted to something, it's the lesser of the evils, certainly.
Right, because just other than stating the obvious of like how many people you'll influence and educate, and you know, like me, like the light bulb goes off just listening to your explanation of things. And it's awesome, like your format and whatnot. Not for nothing, but it's gonna go a long way with people like me. That I lose my attention pretty quick. So if you're not really focusing in where I can like center what's happening, it's like, change it, another thing. And I think everybody's kind of become that way at a point with like social media and stuff. What's your take on that? I know we're kind of getting towards the end here, question wise, and we do appreciate your time and everything. How significant is like social media and emotionally what it's doing to people, instead of saying go lift weights, go outside, read a book? Do you think their advantages outweigh the disadvantages of the effects? I know in Congress, like they're talking about a bunch of people, or a bunch of states rather, are suing Meta now. I think 30 states, because the addiction is basically ruining kids. And I'm like,
Oh, wow.
listening to a newscast, I'm like, it's not just kids, it's like me. I think about it, it's like the first thing I do when I get up is like, if I've got water or something, it's like I have some water because you know, you've been mouth breathing all night.
Of course.
Then it's like, well, I got to check my phone. Like, did I get that email? Did I get that text message? Did somebody like this post? Did somebody share something that I was expecting to see? So yeah, it's not just kids. I'm glad some states are sort of taking an initiative, but I hope it's not just like, well, we're just going to make money and it's a fine. But it's like some of these things really need to be reeled in with social media. Like, what do you think about that? Like, how does it affect your day to day?
Sure. I think something very evocative that I'd heard said in the past, which I think is important, is, you know, psychologically, it has really worsened the compare and despair mentality, right? And something that is really important to remind ourselves is that the facade that you see on social media, that is a constructed facade, right? Like my social media presence is science. Like that is what I put up. That's what I want you to see, right? I have other things like lifting, etc. But there are things that I don't show, and I have a life outside of that, and like, you know, my own struggles and things outside of that. And the one thing that I will say about social media that I think has actually been championed a lot by TikTok is that when I first started doing science communication, social media was really commanded by the Kardashians of the world, right? You were seeing Audemars Piguet watches and people flexing in front of Bentleys, and like Instagram was really just sort of like a Pinterest for like spoiled rich people, right? And you're like,
right.
all of these people had these like phenomenally large platforms, and it was like, oh, you know, they want to see the watch and the champagne popping and all that. And I have seen a massive paradigm shift wherein now content creators that have something to say are being given the platform. And you can see that in like the Kylie Jenners of the world, who take these massive like million follower hits because nobody really wants to see stuff like that. Everybody's like, bro, I can't even afford eggs right now, and you're showing me like all like your new, you know, diamond grill. Like we don't care.
Right.
And I love that. And especially on TikTok, you know, my sort of growth exploded on TikTok, and then Instagram began to follow and has now superseded that. But TikTok is really a platform where what is commodified is not the sort of like champagne popping and whatever. You see like people that are just doing news delivery or are educating on like, you know, historical politics and things like that. And they're the ones with these, like, they get millions of views and it's phenomenal. And so I'm seeing now that at least social media is becoming less about the flex and more about what do people have to say. And I think that as our world becomes a little bit more tumultuous, we're beginning to rally to each other and rally to each other for important things. Now there's still like the BS that exists, but it's becoming, I feel like, less and less aggrandized, which is great. But I do think that it's important to step away from social media. And, you know, myself, I have to be on it by virtue of SciComm, and like you are also on it because you have a podcast, et cetera. And then like Jack, you have the band. And so obviously like promotion, you can't do promotion without social media. You simply can't. But I try to temper that with like, some days I will literally just tell my followers, hey guys, guess what? I'm taking off for a week, and I might post, I might not. And then I won't pick up my phone. And it's those breaths of fresh air that not only help you recenter, but I think when you come back, especially as a content creator, like all of us, helps rejuvenate that. So you're not like beleaguered by doing the thing day after day after day and like after, and it gets exhausting. So
Yeah, for sure.
Yeah, I totally agree, and I've seen exactly the same trend. Even just you know, in the metal community or in the musician community, it's really amazing. Like even if we think, you know, 10, 20 years ago about the facade of, you know, big tour bus parties, girls backstage, like all this stuff that's like a stereotype, and the reality of that not being how it is, but also artists being vulnerable and being human and not being rock stars 24/7 is becoming very popular. I think it's super awesome, and even some of the art is going that way as well. And it's interesting to see people being less curated with their online presence and more just
more
normal,
raw.
vulnerable, and all of these things. Super
Yeah.
awesome.
Yeah, I love it. One of my favorite things is seeing musicians do like backstage tours, and you're like, yeah, here's Harry. He's our sound tech. His belly's out and he's eating a hot dog, you know, and you're like, this is what it looks like. And it's great. I would rather watch that than, you know, like you said, the glitz and the sort of like facade glamour, because you go and you're like, it's not like that.
Yeah, yeah. Like you think about tour bus parties and like all this kind of crazy stuff, and then you come on our tour bus and we're like all sitting in blankets watching Ratatouille and drinking tea. Like
Exactly. Nursing yourself for the next show.
yeah,
Traveling,
exactly.
yeah. I love it.
It's really kind of depressing. You think compared to how it used to be, like someone that wants, they think that being a rock star, being a band is like this lavish thing, and it's like, yeah, we don't have a bus. We're in like an RV, and
Yeah.
it breaks down every 2 days, and nobody's a mechanic because we all decided to be musicians. You know, a friend of mine used to do a special article in like one of the metal magazines, like Rip Magazine or Metal Edge or something back in the day. She was a certified mechanic, and she would do an article every couple months for bands, like this is how you change your tire. This is how you jump start the vehicle if something's not working. Like, this is
Beautiful.
how you check your oil, like all this stuff. And it was like, you know, me coming up, like I've always been around machines. I've always been around motorcycles. I built custom motorcycles. And as a kid, I was taking apart every single thing I had, whether it was a bicycle or a radio or a skateboard. Like, I was taking stuff constantly apart. My whole family, you know, did that. But it's like, wow, I didn't realize people didn't know how to do this. You know, it's kind of one of those things you take for granted that, oh, I know how to do, you know, I can change an air filter, and I can, you know, check transmission fluid and all this crazy stuff. And it's like, being in a band, I think definitely on Jack's level and stuff like that, where you're touring, you're on a label, your fan base is growing, you're all over the world, you're not just playing in a region. I think you become hyper focused on that so much that you don't have time for some of these regular everyday people skills. And also being super artistic and creative, it's almost like, well, I don't have time for that. Like Einstein, I think, go back to Einstein here towards the end. It's like all his clothes were the same. Like he had like black suits, like black t-shirts, which could be probably any of us at this point. But, you know, it's like, well, I'm thinking of equations and processing these things. It's like, I don't have bandwidth back, you know, 100 years ago to be like, well, which shirt do I wear? Or
Of course.
like, you know, I have to make myself breakfast now or something. It's like, no, it's like they're so immersed in that realm of whatever their specialty is. It consumes them.
Yeah.
And I think that's what social media has done. It's, you know, you got states now, like I think Wyoming or Montana, they're trying to pass legislation to ban TikTok. So if you're in one of these states, you won't be able to access it. And do you feel like, is this threat like one of those political things where they're like, well, China has all your information and they're one of our enemies, even though all the stuff we get is pretty much from China at this point? Do you feel like that's really a threat, having TikTok coming out of China from, you know, your standpoint? Like, all your stuff's on there. Like, what would happen suddenly if your TikTok was gone, you know?
I mean, you know, without becoming politicized,
right? Sure.
You know, post Patriot Act, our stuff, everything you do belongs to our government anyway, you know. So it's like, nothing that we create electronically, that we house electronically, that we store electronically, that we develop electronically, is not without eyes on it and is not stored somewhere. I mean, this has already been proven from whistleblowers. So I'm like, whether the American government or the Chinese government has my TikTok videos is irrelevant to me. I'm like, at this point, you know, there is really no autonomy. And that is the reality, is that somebody, some government agency somewhere owns what you have. And it is monitored. And it is something that we as a voting populace voted on after September 11th. And so we voted it in, and like, they're not going to take it down.
So let's all wave to the NSA and the black site guys. Hey,
guys,
it's fine. Everything's on.
I feel
on
like
board
there's
here.
a dude in a dark room somewhere, like, look at her, like, it's Friday night. Does she not have friends? She's out here making science again. Like, they're all literally making fun.
Well, you post that constantly, that's what you're about. So I don't think they
exactly.
even should be too surprised about that.
So yeah, so I don't, you know, if TikTok goes away, it's okay. You know, I think that everybody, like in our space, content creators, we always have a facet. There's always a way to market. There's always a next step. But truly, I do think that the internet, and by virtue social media, it has this ability to be very beautiful, because like, I have friends and in other countries and colleagues that I would have never been able to know existed in the world without sort of the community that is the internet. And, you know, for my part, my follower base includes people who are highly liberal, people who are very conservative, single moms, firefighters, other scientists, people that never graduated from high school, you know. And the beauty is that I've been able to unify this incredibly diverse community of people under the flagship of being enthralled by science. And so yes, do I think social media is destructive? Yes, but I do think that there are content creators out there who are doing unification for the right reasons. And that stands to, I think, overtake the crappiness that comes with social media in the long run. because cream rises to the top, as they say.
Yeah, really well said.
For the most part, yeah. Depends on the
For the most part.
Depends on the particular coffee that cream will be
Exactly.
on top of.
Exactly.
That's so cool to again, you're super consistent in your delivery and your approach to everything. It's you have a very scientific thought process to the way your mind works. So
I do.
all those student loans, as you say, sort of paid off for you, I guess.
Hopefully, now that they're due, I don't know.
Right, right. Now that they're due, exactly. Again, wrapping things up here, you've been so awesome, just educating and entertaining as well. There are a few questions I'd like to sort of sum up in a closing sort of overview, topic wise. That's with science and health. My input is always like, I'm a Trekkie, live long and prosper. I want to know when we will have like nanobots and AI for health reasons, where you don't have to operate. It's caveman to operate. We used to put leeches on people to cure like bipolar and things like that. It is a future in our lifetime, let's say in the next 50 years ish, where science and AI will help with health, like repairing tissue, non-invasive. Like the big thing is like Star Trek, like Bones had a tricorder, and and if someone had a brain hemorrhage, they could set it on there, and whether it was through nanotechnology or vibrating frequencies, it could alleviate whatever the injury was. Is that something real, or is that sci-fi? From like Gene Roddenberry was 100 years ahead of his time, having these things. But is there a real application for health and wellness from technology, AI, and things of that sort?
Sure. So it's probably going to be a bit different than the application of external factors, but really the next biggest thing, the next quantum leap, I will say, in medicine and treating disease is treating it at its most base. And the basis for all human disease, chronic and acute, is the DNA, right? And it is, you look at things like cancer, you look at things like many viruses that integrate into the DNA, et cetera, and then express themselves like at a later period of time. This is all genetic manipulation. And the Nobel Prize was actually awarded somewhat recently in the last year or two for what we call the CRISPR-Cas9 system. And this is a very, very basic, basically gene editing machinery that you can employ. And we have adapted it from bacteria. And so the thing that is going to help us, whether it is aging or cancer or chronic conditions like MS, things like that, that will all be a product of us being able to manipulate in a safe way epigenetic expression, right? How your DNA, is there a mutated gene? Is there like something that got mutated? Go in very quickly, clip it out, replace it with something healthy, boom. And now everything will begin to sort itself out after that. So, the tricorder, maybe not necessarily, but if you could use a tricorder,
it's an app.
Exactly. It's an app on your phone. Or what you could potentially do.
Headache, God.
What you could do is like in your little C port is you could stick a blood sample and have it, very quickly go through your genetic makeup and be like, why are you feeling sluggish lately? Oh, you have like early leukemia. Cool. All right. Here is your,
wow.
Yeah. Like here is your, basically here's your prescription for a new gene. Go in, we'll inject you, and we will, it will go in, and the system works as such that it sort of matches to the gene. So it will unfurl some of your DNA, like lock onto the DNA, clip out the bad stuff, put in good stuff, and be like, okay, cool. Your leukemia is gone now. That's really the next quantum leap. Now, we can do it. We've been able to do it with, the way that DNA is read is like a book. And if you were to consider the way that DNA is structured, like these, we call them base pairs. These are like words or letters that you would read in a book. And so it's like reading through a book and you see like a couple of words are misspelled, but it kind of messes up the entire sentence. And then you're like, this doesn't make sense. So you just go in and you would basically like clip out that word and then put a new word in, and then your DNA reads fine, and everything from there operates seamlessly. So we can do that now, but we don't know how to do it safely where it doesn't affect other things in the DNA strand. So that's our biggest thing. Like, how do we get our head around safely manipulating DNA?
Right.
I
Now
can
you
see a
did,
lot of people who are afraid of things they don't understand being very upset about that.
Oh my gosh, of course, especially post-vaccine era where I was like, oh my gosh, like this vaccine is so elegant. This is the most elegant thing we've ever done with mRNA. And everybody's like, it changes your DNA. And I'm like, those
They're
two things
trying to
don't.
make us into dolphins.
I know. And I was like, yeah, but don't you want to be a dolphin? That's pretty sick.
absolutely. Why
Yeah,
not?
you know what I want is not to have a cold.
Yeah.
So
I want to not feel like garbage for a couple of weeks. That would
Well,
be cool.
just live in a bubble and you probably would be fine with that.
Just be bubble boy.
Yeah, it'd be great. It's so funny. Yeah, obviously you start talking about vaccines and it's like the light bulbs go off and stuff. For the few people I know that are like just off the chain, way farther than I am on the conspiracy ladder. And I want to know the answer to this too, like from someone that's a science educator. Why do so many vaccines take years and years and years and years to get approved? What's the difference? So like the friends I have, they're like family members will watch this and listen. How do you explain to them, like, we were able to come up with the M.N.R.A vaccine and get it approved and it works within, say, like a year. Even though there were patents on it, I read this, that Fauci had patents from 10 or more years ago on a potential vaccine or something like this. So the data was out there in the ether to possibly cure this. But how was it done so quickly and safely? And what does that say for the years and years and years and years it took for all the other vaccines that are out there?
Right. So the mRNA technology, these were things that had already been in the process of being researched, right? So it's not like they were starting from scratch. But I can tell you anecdotally, actually, at the time when COVID hit, I was working for the Cleveland Clinic Oncology Center. So I was doing cancer research. And basically what the FDA did, because a lot of the waiting period and why vaccines take so long is that there is an incredible amount of downtime when you're waiting for the FDA to get back to you, right? So you can send the FDA a letter and be like, hey, I'm interested in starting this trial. And it could take weeks for them to schedule a call and be like, okay, cool. Well, we don't like this word in the second paragraph of the third page. Can you go and edit that word? And then we will consider it again. So you go and edit one word, send it back. It takes weeks and weeks and weeks, right? So there's a lot of just like bureaucratic downtime because it is a government agency. It operates very slowly. So at the time of COVID, I was pushing through a protocol for FDA approval to employ B12, the vitamin B12, to treat joint pain in women that were undergoing breast cancer treatment, right? This is a very common thing for some of those drugs. And B12 helps possibly with joint pain. And it's something over the counter and you can take it. It's super safe. You can take it like in excess of 30,000% of its daily recommended intake. And it does nothing. Like it's a very inert thing. So this is something that should have been passed through the FDA very quickly, right? Because it's just a vitamin. And the FDA, the project that I had going, they completely sidebarred it for COVID. So the FDA said, all right, here's this like sea of all of these cool projects. And they literally did like a Moses and they were like, boop, everybody is literally pending until further notice. So the FDA just gave this massively clear runway for evaluation. So the normal, like, I mean, you're talking these processes you're sitting there as a scientist and you've done the research and you're just waiting on the FDA to respond to you or trying to schedule calls with like their pharmacologists in house. And you're sitting on your hands for cumulatively years or months or years just waiting. And so a lot of that fast tracking was the FDA being like, every other project that is not COVID vaccine related is now sidebarred. So they just had a bunch more resources to dedicate to it and personnel and time. And then everybody was staying over late and everything in those offices trying to get things done.
Wow. So how, moving forward in the future, do we separate those roadblocks so something like your project can get through faster? Is it just come down to money? It's like, who's paying for this stuff? Why are we going to Mars when we should be paying for more approvals of vaccines and things like that to help us here?
I think a lot of it is prioritization. So, like the FDA, like they will put more attention on something like maybe a groundbreaking cancer pharmaceutical or a groundbreaking cancer biologic, because that impacts so many human lives. So a lot of it is just weighing of the literally millions of protocols that they probably field every few years, because there are so many labs that want to do things and investigate things, but they can't without FDA approving it first. You know, a lot of it is just what are the basically dumpster fires right now in human health that we need to put out immediately. And a lot of that is like, you know, cancer related things, or like very like significant age related things like Alzheimer's, et cetera. So when you go to like clinical trials and you type in, you know, breast cancer or like Alzheimer's, you'll see that there's so much research that is passed, because these are really important things, especially as our population ages overall, that if we don't get a handle on these chronic conditions, it will break our medical system. So the FDA is like, we need to do what we can to at least have good treatment modalities quicker. And so they sort of fast track stuff like that. And then everything else just kind of falls in line. So like my B12 thing, they're like, that's cute, but like, we're also trying to cure cancer. And I'm like, no problem. I get it.
That being said, though, you can put out something privately that's, or for the public, it's like B12 can be used for this, but you have to put the disclaimer like this has not been approved by FDA. Because I see like supplements all the time, and not eating animal products. B12 is like the first thing behind where to get your protein. Is like, what about B12? And people don't understand how much B12 is injected into animals, because we used to get it from dirt. You know, you would eat organisms and things were in dirt, but now everything has been so sterilized that the animals get it. So the way people get it that eat meat is because it was injected. But what does the landscape look like for you to be like, I can release this without FDA? Is it just not taken seriously if you go that route, like a supplement?
Right. So it's funny that I have a massive section about that written in my second book that I'm drafting right now.
I remote viewed it, by the way. And I gave you the name for it. We won't tell the name to anybody.
So the essentially the FDA passed legislation some time ago, decades ago, that said that you are not required to get their approval to market something if you are not saying you are treating a specific disease. So every single vitamin, every single supplement, and even things like NyQuil, Tylenol, Robitussin, everything in your medicine cabinets right now, unless it is prescription based, is not cleared by the FDA. Nothing. As long as they say, and all they have to do is walk that language line and not say that it's, oh, this is meant to treat this X, Y, or Z, they are allowed to not receive FDA approval. And then the burden falls back on the FDA. And the burden is the FDA has to then go into this great deal of trouble to prove harm to pull something off the market, which is a tenuous line, because the FDA has to be alerted to it, then they have to do an investigation, and then they have to pull it. So you could technically have somebody that puts out bunk supplementation and a bunch of people get sick from it because it's contaminated or something. And the FDA has to go through the legal process before they can pull it, because of the legislation that the American people voted on. They wanted it this way to be able to have vitamins and supplements readily available. So your vitamins and supplements are not only not FDA cleared, but unless it says on the packaging that it has been tested by a third-party lab for its contents, you may not even be getting, you could be getting mostly sawdust and filler and like not what you think you're getting. So fun fact.
It's
sounds like a lot of the confusion and the problem around all of this FDA stuff comes down to just how long it takes to navigate the bureaucracy on all ends. So this, bringing it back to the AI thing, this could be a beautiful implementation of
AI.
How AI could help is to weed through some of this process and make it more automated, so that it doesn't have to take weeks to years to hear back on one proposal.
Yeah, that's actually a brilliant idea. So you should patent that, and before somebody comes and steals it.
Somebody else please run with that. Like, I don't have time. You fix it.
You're just the idea guy, throwing it out there. My thing would be like, we'll get, as long as the AI is not going to prove something that it knows will kill us. Like, let's stop testing on animals and let's have the AI run all the algorithms, run every single scenario. It's smart enough to do that and say, this will do this and it's approved, and let's move on. Like, I just saw an article that all of your over-the-counter, your Sudafeds, your NyQuils that you mentioned, Robitussin, everyone had Tussin when they was a kid, if you're old enough. none of it does anything. It does not work. That's out in the news. If you Google that or look at the articles, it's like, nope, it's basically placebo effect. It's like, if you take this and you think you're doing better, it's fine. But the main ingredient in all these things is alcohol. That's why kids were like getting like Formula 44M. It had the highest alcohol content, and kids were getting this stuff and getting drunk off of it. So having things like that, how many people have gone and got a bottle of stuff and they go, oh, I need this, and it's like, no, it's alcohol, sugar, and maybe some sawdust sprinkled in there to make you feel better.
Yeah, a lot of it, you know, I think people are under the false impression that things like NyQuil, et cetera, cure the cold, but what it does is it just sort of depresses the expression of symptoms. So it just kind of like takes away some of that inflammation pathway so that you don't notice it, but like you're still symptomatic, like your nose is still going to run. It's just sort of depressing it for the time that it's working in your system, but it doesn't cure anything. It just helps you with the sniffles.
And being on the road in a band, we used to get Jaeger, and I swore by Jaeger whenever I started to feel like I was getting sick. I would take like 3 shots of Jaeger, and I did not get a cold. I did not get sick for several years. But supposedly the water that they use in Germany, where they actually brew the Jaeger, runs through poppy fields. So whether or not that's true is all up for grabs. So somebody find that out too. Get the AI to figure that one out. Well, Leah, I really, really enjoyed talking to you so much. You covered everything and more for sure than what we had planned. But here, rolling out towards the end, please plug anything that you would like to say. I know you got another book coming out. I have no idea how you're going to stay on top of all these things. So you're sort of the Jedi Master as the StEMPIRE strikes back. I like to say as a role model for people that want to do all these things and be successful and educate. You know, the whole point of our podcast is like, I want people to see this that maybe learn something that they didn't know. And we hope everything is factual, but please, anyone, feel free to certainly fact check me on stuff, because the memory, as they say, is not what it used to be. But yeah, anything you'd like to say in closing here? And again, I can't thank you enough for sharing your time that obviously is so super valuable right now.
Sure. Well, thank you guys so much for having me. It's been an absolute pleasure. And I think the only thing that I would want to plug is just a kind of a call to action for any of my scientific colleagues out there. You know, we're sort of in this era where misinformation is very easily spread. And a lot of people, they, you know, they take authority figures, quote unquote, in social media as fact. And that's how you spread a lot of pseudoscience. And so the best way to combat pseudoscience is with real science. And so I encourage all my colleagues out there to fight the good fight, you know, give back to the public. If the public doesn't understand science, that's on us and it's our fault. So it's our job to champion it as the experts. So join me. It's fun out here screaming into the void.
Awesome.
That's awesome. I feel like I could listen to you explain things for hours, and I'm probably going to. I'm going to go binge watch all of your videos now. So.
Yeah,
I appreciate that.
Yeah, I first started watching her old podcast, and I was like, this is really cool. It's we hit a lot of things very similar, like talking about Lord of the Rings and different RPG stuff. And I was bummed to see it was only a certain number of episodes, but obviously what you're doing now is far and above that. Please keep us in mind. Anything you'd like to have a music tint to it. I'd love to see something talking about, and I'm working on this myself, is a health related thing for bands, much like my friend was doing, you know, roadside maintenance to help bands. But, you know, I'd really like to help bands and people I know get on a healthy track, because and Jack can attest to this, it's like when you get off the road, it's like, I have to eat real food. Like I cannot do another bar burger anymore.
Right.
But your presentation style, I think a lot of bands, and you being familiar with a lot of people in the industry, I think that would be something to help a ton of people that would benefit immensely from it.
Yeah, absolutely. It's a great idea. I'm sure it can apply cross functionally to music and probably everyone else in a certain extent as well.
For real. Great. Well, thank you so much again, Leah, Jack. Thanks for hanging out and keeping it real. And we'd like to thank all the followers and likers that are still keeping with us. I think I looked the other day, and for a new podcast that nobody knows about, I think we had 2,500 hours of viewing time, which
Congratulations.
I don't know. I'm sure numbers wise, that's nothing, but we had 0 before we started this podcast. So it's something to us. But thanks again, everybody, for watching and hanging out. Please follow Leah. Her website is leahelson.com, I believe. And Gnarly by Gnature on Instagram and TikTok. I have a TikTok and I just don't get it, but I'll go on there, and if I'm not following you already, I'll definitely dive into it. I want to see more science stuff. If I could weed out the stuff somehow that I really don't care to see, I'd like to do that. So maybe you can send me some algorithms to help with that.
Got you.
Awesome. Well, thanks again, everybody. This has been Sounds and Grounds. We appreciate you. Get them science gears turning and learning and burning, and stay cool and stay metal. We'll see you next time.